Hey there, I wanted to put together this quick video to talk about Terraform and introduce the concept of Terraform and what you would use it for in your environment. Now, this video isn't necessarily intended to teach you all about Terraform and how to use it, but merely just to get started with Terraform and understand what Terraform is, what are the benefits of it, what is it, and how you can get started in your own environment. So first of all, let's introduce Terraform. Now, Terraform is developed by a company called HashiCorp. Now, HashiCorp is relatively famous for Terraform itself, but it also has other critical tools that many businesses use, such as Nomad, HashiCorp Vault, Console, Packer, Vagrant. Those are probably tools that you've heard about before. Now, Terraform is an extremely popular infrastructure as code tool. And what it's going to allow you to do is really automate the provisioning, management, and versioning of your infrastructure. So think about today if you are using the console to deploy infrastructure in your environment. Maybe you're logging into AWS or VMware or Azure or GCP or whatever the platform of choice would be. And you're clicking around the console to deploy virtual machines, containers, networking constructs, those kind of things. What we can do is we can take all of that infrastructure and we can codify it, and we can use Terraform to deploy that instead of clicking around the console. Now, when you're creating Terraform configurations, we're going to use HashiCorp's configuration language, or HCL, to define our infrastructure. Now, Terraform is platform agnostic, and what that means is Terraform can support many different types of platforms where you want to deploy your infrastructure. So if you want to deploy infrastructure on a public cloud, Terraform supports that. If you want to deploy infrastructure on your on-premises data center, maybe using VMware or Nutanix, well, Terraform also supports that as well. If you want to configure DNS records or support some other type of SaaS solution, well, Terraform also supports that. So Terraform will allow you this consistent workflow, and that's regardless of where you're going to deploy and provision your resources. Now let's talk about some of the benefits of infrastructure as code in general. Now the first one is version control and auditability. Now infrastructure changes are going to be tracked using version control systems, and it's going to provide a clear history and the ability to revert back to previous configurations. Now if you think about clicking around in the console, now, there's no version control for clicking around with a mouse. You can't necessarily go back to what you did without a human logging into the console and reverting those changes. Now, when you're using Terraform to deploy all these things, or just generally infrastructure as code, well, you can check in this code to version control, and now you can keep track of all the changes that are going to be made in your infrastructure. You can also audit those changes, so understand who made those changes, and of course, revert back to previous configurations if someone accidentally pushed up some code that caused some issues with your production deployment. Infrastructure as code also enables automation and efficiency. So it's going to allow you to automate the provisioning and management of your infrastructure, again, without having somebody go in and click around in the console. Now, this is going to reduce all those manual tasks that are required by human beings, and it's going to accelerate your deployment time because you already have this infrastructure codified, and you can simply push the changes up to your platform of choice and deploy your infrastructure versus having to wait for somebody to go around and click around in the console. Infrastructure as code also enables this really scalability and flexibility in your environment. You can quickly scale infrastructure up and down to adapt to changing requirements by simply modifying code instead of manually changing your resources. For example, if you have a cluster of web servers out there that's running 3 nodes and you notice that traffic is really increasing, well, instead of having to go into the console and changing that, you can simply change a variable from the number 3 to 5 and use Terraform to push that code, and it will simply update the number of web servers in your web farm to support the increased changes that are happening in your environment. So it's an easy way to be able to scale your environment quickly, and of course you can scale it down as well. Right, say in the afternoon you don't have a high workload, or in the weekends you want to scale your infrastructure way down to save on costs, but you can quickly do that as well using infrastructure as code. Infrastructure as code also enables collaboration. I mentioned before that you would codify all of your infrastructure and check that into version control. Well, by doing so, now different teams can actually collaborate on those infrastructure changes, just like they would when they're developing a new application. Now, by collaborating on changes that are going to impact your infrastructure, you really start improving your transparency and you reduce those silos in operations because now you have multiple team members, maybe even different teams that are collaborating on these changes and they understand what's going on in the environment. And finally, the other benefit is consistency and repeatability. If you codify your infrastructure and it's the same each time, well, it's going to be extremely consistent. If you need to make sure that all of your servers are alike, well, again, it's codified. So all you do is push changes. It's going to be exactly the same every time. You can reduce your configuration drift and reduce or eliminate human errors by codifying your infrastructure and using something like Terraform to push that code to your platform of choice to deploy your infrastructure. So you can see that there are a lot of different benefits for using infrastructure as code as a whole versus going into the console and clicking around and deploying all your stuff manually. Let's step back and compare Terraform with other infrastructure as code tools that you've probably heard about in the past. So the first one is AWS CloudFormation. The second one is Azure Bicep. And the third one I'll compare to is Pulumi. Now, these are all infrastructure provisioning and management tools. They do very similar things as Terraform. The idea is that we're going to provision and manage our infrastructure on our platform of choice. When you look at AWS CloudFormation or Azure Bicep, those are specifically geared towards that platform of choice. You're going to use AWS CloudFormation to deploy infrastructure and resources that live on AWS. You're going to use Azure Bicep to deploy infrastructure that lives on Azure. All right, you're not going to use Azure Bicep to deploy resources on AWS. They're not going to support that because they want you to consume resources on their cloud. Now, Pulumi is more similar to Terraform in the fact that it is platform agnostic and it supports multiple target platforms. So it supports AWS, Azure, GCP, other SaaS products, other cloud platforms. So again, these are all tools that are focused on infrastructure provisioning and management. They all use a declarative language. They all focus on immutable infrastructure, although you can manage infrastructure that lives for a long time. And they all focus on modular designs where you can create what's called modules and then stitch all those modules together to create a holistic solution. And we'll talk about that in a minute. Now, other infrastructure as code tools that you may have heard about include Ansible, Chef, and Puppet. Now, these infrastructure as code tools are really focused on configuration management, right? They are somewhat different than Terraform and AWS CloudFormation and Bicep. They focus more on installing packages and managing files for you in your environment. The idea behind configuration management tools is managing the configuration of your existing systems or managing the configuration when they are first deployed. The idea is that you can push out a desired configuration to your servers and your infrastructure, and then these tools can actually go out and ensure that the infrastructure still meets that desired configuration. And if it doesn't, it can actually revert those changes back to make sure it meets that desired configuration. So say, for example, you push out configuration changes using Ansible, and then you have a system administrator that turns around and makes a manual change on a server. Well, these tools, including Ansible, Chef, Puppet, SaltStack, will actually notice those changes and it can actually revert those changes back to match your desired configuration on that server. So it's a way that you can manage configuration of new servers and actually manage configuration of existing servers. You can also use these tools to automate things like routine tasks and orchestrate multiple step tasks. So for example, if you have a static environment, but you need to make changes across all the hosts that make up that static environment, you can use something like Ansible to go out and make all those changes across all those servers at one time, and it reduces the manual configuration of all those servers. We don't need humans to go and manage all those servers. And well, as a system administrator, I don't need to log into each one of those nodes and make that same change over and over and over. We can push out those changes using something like Ansible. So those are really the differences between a lot of the infrastructure as code tools you've seen out there before. Again, on the left, these are really similar to Terraform, right? They're focused on infrastructure provisioning and management, where the products on the right are different, right, but often complementary. And what I mean by that is many times we're using something like Terraform, but we're also using something like Ansible as configuration management to manage the configuration of your infrastructure after it's deployed using Terraform. So Terraform would go out and deploy your virtual machines, and then we use something like Ansible to go out and configure those virtual machines to our desired state. So again, there's a little bit of difference between them. They are definitely different, but again, they're generally complementary to our infrastructure provisioning and management tools that we see on our left. All right, so let's jump into Terraform here. What does Terraform, or really any other infrastructure as code tool, do for us? Say, for example, you need to go deploy a new virtual machine on your public cloud. So you would maybe log into AWS, you would go into the EC2 dashboard, and you click on that blue button that says Launch Instance, you go configure it, and you launch your new virtual machine. Well, you do the same thing in, say, VMware, right? You go into your cluster, you say new virtual machine, maybe we're going to deploy it from a template. We're going to say how big it is, how many CPUs, how much memory, how big the drives are, what operating system we want it, etc. We go deploy our virtual machine. And finally, maybe we do the same thing on Azure as well. We go and deploy a virtual machine. And ultimately what we end up with is, well, our virtual machine, a container, a network, some type of resource that lives on the platform of choice. So that's what we would generally do without Terraform. Well, when we introduce Terraform, well, we can take all those configurations that we just made in the console and, well, we can put them in code. We can simply codify all those infrastructure resources that we just created in the console, and we can use that to go deploy our application workloads, go deploy our network infrastructure, subnets, NAT gateways, whatever you need in your infrastructure in order for your application to run. So we can simply take that and we can use that in our environment. Now, the best part about codifying our infrastructure is that code is going to be reusable. We can simply write code once using variables as you see on the screen, and then we can deploy multiple instances for different applications. So let's see what that looks like. So say, for example, we take our resource here, which is basic server, but you see everything inside of this basic server is pointing to either variables or data lookups. What we can do is we can provide some input variables in there. So for example, the AMI is Ubuntu, the subnet is 10.16.7.0, and the app is web server. We can simply use those variables with our resource, and we end up with our web application. Great. Now what we can do is we can also use that same code, but we feed it in different input variables. So for example, in this case, the AMI may be Windows based, the subnet is 10.0.3.0, and the app in this case is data processing. We feed in those input variables, and the output that we get is our data application. So again, we can use this same code, and by codifying our infrastructure, we can simply provide different input variables, and we end up with a completely different workload. So you can see how beneficial it is by creating our infrastructure as code and simply reusing that in order to create different workloads. So let's take this one step further and see how we can reuse our code. Let's say that we start creating our Terraform code. And as we are working in our environment, we find that we're writing network configurations. We're writing subnet configurations, configurations for NAT gateway, load balancers, different types of virtual machines, maybe even a Kubernetes cluster, a database, messaging service. All of these are resources that many organizations use to make up their applications. One of the key concepts of Terraform is called dry, which is don't repeat yourself. So you saw on the last slide where I was able to take that same code and reuse it to create different output scenarios. Well, we can do the same thing using Terraform. What we do is we create what's called modules. And these modules are going to create a specific resource for us. But since we use input variables, we can use those variables to change the output without having to completely rewrite our code. So say, for example, we get a new requirement for a new application. What we can do is, instead of writing all of our Terraform from scratch, we can simply create and deploy our application from our list of approved modules from within the organization. And that's going to allow us to simply use approved modules without having to rewrite our Terraform. So what we can do is say, maybe we need a network, we need a subnet where our application is going to run. We need a load balancer because we're going to add multiple virtual machines as part of our application. Maybe we need a database too. So we can simply grab and point to these different modules for our application and then deploy our application as it's needed to meet the requirements by our application developers. Say, for example, we need a Kubernetes cluster. We can grab the module for that and simply point to that and deploy a cluster like that as well. So again, one of the core benefits of codifying your infrastructure is the ability to reuse your code. Once you write a module for these things like network, subnet, database, etc., we can simply reuse that and then create our new workloads based upon those modules without having to rewrite our code each time. So huge benefit there. All right, so let's take a look at the core components of Terraform. Now, first we have Terraform Core. A Terraform Core is really that binary that we're going to download from HashiCorp. It's that CLI tool that's going to provision and manage our infrastructure resources as defined in our configuration files. All right. Now we have providers. Now providers are going to extend the functionality of Terraform Core by adding specific resources that target platforms such as public cloud providers, different SaaS offerings, hardware platforms, right? It's going to extend the functionality. So for example, if we want to deploy infrastructure on VMware, well, there's a VMware provider that we would simply point to and download, and that extends the functionality of Terraform, and now we can deploy all these different resources that are supported by VMware. Same thing for AWS, Azure, GCP. There are literally thousands of providers that you can pull down. There's even a provider for Domino's Pizza if you want to use Terraform to order pizza. So you can extend the functionality of Terraform by using providers. Now, the next one are our resources. Our resources are all those things that we just talked about. Our subnets, our virtual machines, our Kubernetes cluster, our containers. Those are all things that we want to ultimately deploy on our target platform in order to support our configuration, in order to support our applications. So you may deploy virtual machines and you may need DNS configurations to support pointing to your application so your users can access your applications. Well, you can do that with Terraform. So a resource is really any of those components or services that you need to manage using Terraform. Now let's talk about state. State is a very important component of Terraform, and it's how Terraform maps our desired configuration, meaning what we write inside of our code, with real-world resources that are running on our target platform. So say, for example, we create some Terraform that deploys a virtual machine on VMware, and then we use that Terraform to provision that resource. Well, state is going to kind of map out, okay, I have the resource in my configuration file, and now I actually have a virtual machine running on VMware. State does that mapping between the two. And it ensures that what you have in your configuration file, which is often called your desired configuration, matches exactly what you have in the real world. And the job of state is to ensure that any changes made to your configuration file are also applied to the real world configuration. And the last one here is modules. So we talked about modules before, the ability to reuse code. So modules are reusable and shareable blocks of code that can be called over and over again. Again, if we create one module for a virtual machine, we can call that 1,000 times and create 1,000 different types of virtual machines that are going to support our workload. Again, modules are that component that will allow us to reuse that code and speed up our delivery of our applications by simply calling modules and creating our workloads. So now that we know more about the core components of Terraform, let's take a look at the Terraform workflow and see how do we actually use it. Well, the first thing we need to do is, well, develop our configurations. You saw in the previous examples where I had a resource defined for a virtual machine. Well, we need to do that for all the resources that we want to deploy in our infrastructure. So develop a configuration for a subnet, a load balancer, a database, right? We create and write those configurations using HashiCorp configuration language, and we define the resources that we want to deploy. Now, once we have that, the next thing we need to do is initialize. Now, initialization is going to set up our environment, and we're going to use the command called Terraform init to do that. So that's going to initialize our backend. That's going to initialize, make sure we have credentials in order to target the platform of choice, all those good things. It's going to ensure that we're ready to go. Now, the next thing we're going to do is a Terraform plan. Now, plan is really going to provide a preview of any changes we're going to make with Terraform. So say, for example, we have a brand new environment and we run a Terraform plan using our configuration. Well, Terraform plan is going to look at our configuration and it's going to reply back and say, you know what, we're going to deploy our database, our subnet, our network, our Kubernetes cluster, because that's what was defined in our configuration. Now, if you were to go back and make changes to that after you deploy it, it's going to look at the existing configuration, it's going to look at the real world configuration, and it's going to look at the differences between the two. So if you take my example before where we had a web farm of 3 and we wanted to change it to 5, and we simply change a variable from 3 to 5 and we run a plan, well, the plan is going to notice that we only have 3 servers deployed out on our infrastructure, but now our desired configuration says we want 5. So the plan is going to report back saying we're going to add 2 more to make sure your configuration in the real world matches your desired configuration. So that's what a Terraform plan is going to do. It's going to plan and preview changes that are going to be made when you actually run and apply. So let's talk about apply. Apply is going to deploy our infrastructure. So it's going to actually make changes to our target platform based upon what you've added in your configuration files. So again, if you go and create a bunch of subnets in your configuration file, you run a plan, it's going to say, hey, I'm going to deploy all these subnets. Now you run an apply. That's when Terraform actually interacts with the target platform's APIs and deploys those subnets. Now, if you go back and reduce some of those subnets and you run and apply again, that's when Terraform is going to go back to the target platform and delete those subnets from the target platform. Okay, so apply is actually when Terraform makes changes to your real world infrastructure based upon the configurations that you have in your configuration files. And finally, once you've deployed all your infrastructure and you want to maybe tear it down, well, you can use Terraform destroy to tear down infrastructure. So say, for example, you want to save on costs on a public cloud platform and you want to destroy those resources, well, you can simply run a Terraform destroy and Terraform will go back to that target platform and delete those resources that it's managing. Now, note that Terraform doesn't touch anything else that it's managing, right? So say, for example, your Terraform deploys 5 virtual machines. Well, if you run a destroy, Terraform will only go delete those 5 virtual machines, even if you have 500 other virtual machines that were created some other manual way. So Terraform will not touch infrastructure that it is not managing. It will only destroy that infrastructure it knows about in the state file. Again, so that's why state is very important. So that's your basic Terraform workflow. We're going to create or develop our configuration. We're going to initialize our directory where you're running in. And once we're going to run a plan to preview any of those changes. Once we like that, we're going to apply those changes to our platform. And finally, if we want to get rid of those resources, we can run a destroy. So how do we actually get started with Terraform? Well, the first thing we need to do is download the appropriate binary for your operating system. Whether you're running on Windows, Mac OS, Linux, other platforms that are supported by Terraform, you can go to terraform.io, download the binary of choice, and install it on your machine. Now, once you're ready to do that, you can set up your workspace by creating a new directory to organize your project. And then maybe you also want to create or initialize a new Git repository to track those changes using VS Code or similar tools, right? Many times when we are working with Terraform, we're going to check in this code into a Git repository, again, so we can version control it, we can track changes, we can collaborate with our teammates. So many times we're creating directories in a similar fashion of creating directories when we're working on an application or anything else. We're going to create our directory in order to store all of our files that we're going to use for Terraform. Now, once we have that, Well, we're going to set up credentials for our preferred cloud provider. Just like you would when you log into the UI of any cloud provider or target platform, you need to authenticate in order to access your account. Well, Terraform needs the same thing. If you're going to deploy against AWS or GCP or VMware or any other SaaS platform, Terraform needs to authenticate with that platform so it knows what account to deploy it in, and it ensures that we have permissions to deploy to that account. So you need to provide credentials to Terraform in order to access that target platform. Well, once we have all that, we can write our first Terraform configuration, and we'll generally start with some basic resources and we'll iterate and improve from there. So we can create our first Terraform files, create our first resources, maybe create some variables and deploy that to our target platform to get started. So hopefully this gives you a good idea, an introduction to Terraform, understanding what Terraform does, how it does it, and how you can get started with Terraform.